Okay, so we discuss logical address, virtual address, then we use the bytes, BYTS to determine the size, then bits to determine the address. The capacity is measured with the help of bytes and address written with the bits. Then we discuss physical memory, that means random access memory. It contains the frames. So it also address mentioned with the bits and capacity with the bytes. Then paging mean frame size and the page size and the paging file size should be equal. Divide the equal size of blocks. We call paging. If it is in the RAM, we call frames. If the block is in the virtual memory, we call pages. The program file divided into same blocks we call as paging file. Then we discuss the mapping. Pages and frames are there. So pages in the virtual memory, frames are in the random access memory. So from the virtual memory to random access memory, paging files are moving. Here the page 0, the file which was there in the page 0 moving to the frame 0. The paging file is moving to the frame 0. Then therefore it is present. So page 3 paging file is not moving to the random access memory because there's no frame dedicated to move the page 3 file. So because there's no frame allocated there, we call page 3 is reside in the virtual memory. But page 0, 1, 2 are moving to the random access memory with the help of these frame numbers. So page 0 carrying by the frame 4, page 1 is carrying by the frame number 2, page 2 is carrying by the frame, page 2 file, paging file is carrying by the frame 7. So actually page is not moving, only the paging file is moving. The paging file which was there in the 0th page is moving to the frame number 0, frame number 4. The paging file which was there in the page 1 is moving to the frame number 2. Paging file which was there in the page 2 moving to the frame number 7. So those files are in the random access memory now, but only the paging 3, the file which was there in the paging 3, page 3 is there in the virtual memory. So then we discuss the advantages of paging. Then we discuss the parts of the virtual memory and the physical memory. So physical address divided into 2 sections, frame number and the frame offset. So frame size is equal to page size. Then page also paging address, that means virtual memory address also divided into 2, page number and the page offset. Then frame offset sum equal to page offset. Then we have done these calculations last week. Then I think we have already discussed this one also. Okay, so the final one, yeah, we did this one. Now look at, assume that 2 bits per page, if the page containing 2 bits for the page number and 3 bits per page offset. 2 bits used for the page number. That is 2 to the power 2 possibilities are there for the page number. Okay, 2 to the power 2 possibilities are there in the page number. Then if there are 3 page offset, 3 bits for the page offset, that means 2 to the power 3 possibilities are there in the page offset. So page 0 containing, that means there are pages 0, 1, 2, 3. Altogether 4 pages are there. Why? 2 to the power 2 is 4. Then page offset, there are 2 to the power 3, that is 8. So page 0, offset 0, page 0, offset 1, 2, like that, up to offset 7. Then page 1, offset starting from 8 to 15. Page 2, page offset starting from 16 to 23. Page 3, offset starting 24 to 31, like we discussed last week. Then today, we are going to discuss about the physical address. Physical address in the sense we are going to discuss about the frames. An address available in memory unit present in bits. The loader generates physical address at the time when the program is loaded in the main memory. Physical address is divided into two sections. Frame number, number of bits required to represent the frame. No need to write the F and D, don't write it. Frame number, the number of bits required to represent. Frame of physical address space. Another name, frame number. These names are using the frame offset, number of bits required to represent the particular word in frame. Frame size of physical address or the words number of frames or frame offset. These blue color names can be used for the frame offset. Word number of a frame or frame offset, these words are used. Okay, then we are going to discuss the calculation. So this is about the frame that is in the random access memory. We'll copy down this one. How to find the frame offset from the given frames. So where is the frames? Frames are in the random access memory. So we are going to find out the frame offset. So first, get the frame offset by calculating. Frame offset in bits equal log frame size in bytes. Log 2 frame size in bytes. So normally bytes are in kilobyte, megabyte. So now here I have given if frame size is 16 kilobytes, 16 KB. 16 KB mean 2 to the power what? 16 mean 2 to the power 4. Okay. KB mean 2 to the power 10. Altogether 2 to the power 14 bytes are there for the frame size. Entire frame contains 2 to the power 14 bytes. Okay. Then we are going to convert it into bits. Frame offset bits equal log 2 frame size in byte. That is, we can write log 2 to the power 14 is equal to 14 bits. Can you understand the process there? Then log 2 to the power 14 is equal to 14 bits. This 2 to the power 14 mean bytes. I think grade 11 you have done it. Log 2 to the power 14, we can write it as 14 bits. Like 14 we can write. Okay. So the frame offset is 14 bits. Okay, so if you get a question asking the frame offset in bits, log 2 base 2 frame offset in bytes, B by TS, we can write it as log 2 to the power 14 equal 14 bits. Shall we write it? This is equal to 14 bits. Okay, quickly copy down this one. Page size is 16 KB, kilobytes. That's the size. Normally size writing with the bytes. Okay, so page size in bytes equals 16 multiplied by 2 to the power 10 bytes. That is 2 to the power 4 multiplied by 2 to the power 10 bytes. We can write 2 to the power 14 bytes. Page offset bits equal log 2 to the power 14 bytes, BYTS. That is equal to 14 bits. If you want, copy down this. Okay. Now look at this one. Total number of bits allocated for virtual address equal page number plus page address. Virtual address equal page number plus page offset. If the virtual address is 16 bits, then calculate the physical page number. If the virtual address is 16, virtual memory address is 16, then asking to find out the physical page number. So virtual address equal page number plus page offset. So 16 bits equal page number plus 14. Page offset is 14 because we have already got the answer page offset 14 bits. Then what is the page number? Page number is equal to 16 bits minus 14. So page number equal virtual memory address minus page offset. 16 minus 14, that is 2 bits. So page number 2 bits, page offset 14 bits. Total number of virtual addresses are 2 to the power 16, 65,536 because there are 16 bits are there. 2 to the power 16 means 65,536. Total number of pages 2 to the power 2 because there are 2 bits. 2 to the power 2 possibilities are there. That is 4. Total number of offset per page. Offset there are 14 bits. Then it will be 2 to the power 14. That means 2 to the power 10 means 1024 multiplied by 2 to the power 4 means 16. So answer will be 16,384. So in your exam, no need to simplify further. If you keep the answer with the power value, never mind. Don't waste the time to find out the final simplified answer. Keep it in the power value. Okay. Then copy down this one.